Alright, so we just learned that standard deviation can really be affected by outliers. So how do you talk about the spread of data if you've got an outlier, or if your data is skewed? Well, there's the interquartile range. The interquartile range is a measure of variability or spread that is resistant to the effects of outliers. It is based on quantities called quartiles, which divide the data into quarters. 25%, 25%, 25%, 25%. We use Q1 for the lower quartile, Q3 for the upper quartile. The lower quartile is the median of the lower half, the upper quartile is the median of the upper half, so it's the middle of the middle, kinda. If n is odd, so if there's an odd number of things, the median of the entire data set is removed or excluded from both halves. So for example, if we were dealing with 1, 2, 3, 4, and 5, and I said find the, let's do even first. So to find the median, you would separate it out like that. So the median would be 3.5, and then 2 would be the first quartile, and 5 would be the third quartile. It's the middle of the upper half. If you have an odd number, when you're finding the quartiles, you take out the middle, and then you do the middle of this, which would be 1.5. So the lower quartile is 1.5, and the upper quartile is 4.5. That's how you do it. The interquartile range, IQR, as we're going to see it. The interquartile range. Remember, range is you take the largest minus the smallest. So, but the interquartile range is the third quartile minus the lower quartile. I mean, you also see upper minus lower, upper quartile minus lower quartile. Interquartile range measures how spread out the middle half of the data is. So the middle half of the data doesn't include the outliers. Okay, so that's why it's resistant to the effect of outliers. Okay, so in this scenario, what's the median? What's the median and the quartiles here? So here you can split this up. There's the first 5. There's the second 5. The median is 5.5. The quartile 1 is 3. Quartile 3, or the third quartile, is 8. And therefore the interquartile range is 8 minus 3, which is 5. For this one, to find the median, you go to the middle. So you go in 5. You go in 5. In this scenario, the median is 6. To find the quartiles, you take the median out, and the lower quartile is still 3. The upper quartile is now 9, for an interquartile range of 9 minus 3, which is 6. Okay. Consider the data set from example 1. Find those numbers. So pause the video and find the quartiles and the interquartile range. Okay, now you're back. The data is separated here. That's the first quartile. I got lots of pens. First quartile. Second quartile. I'm saying that wrong. Bottom 25%, lower middle 25%, upper middle 25%, and There's the top 25%. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 here, 10 in red, 10 in green, 10 in purple. Alright, so hopefully you figured out the third quartile would have been right around here, 20.5. The first quartile would have been right here. It's the middle of the lower half, so 4.5. And the interquartile range is 20.5 minus 4.5, which is 16. Next. The 5-number summary is the following. You have the minimum, the first quartile, the median, the third quartile, and the maximum. That's called the 5-number summary. That will be asked for, so you need to know what the 5-number summary is. It's these 5 numbers of a data set. A box plot shows the 5-number summary. Okay. So to construct a box plot, compute the values in the 5-number summary. So for example, actually just pause the video and read through this. And we're back. We'll compute one of these in a minute. One thing to notice, we're finally given a definition for outliers. We'll do a box plot in just a second. Outliers finally gives a definition. Here's how we define an outlier. An outlier is too small. It's a small outlier if the value is less than the first quartile minus 1.5 times the interquartile range. That's how we've defined it. And we mean statisticians. Where does 1.5 come from? Well, it's kind of arbitrary. We get this in AP statistics. You don't really get this in AP calc. But there are things in stats that are kind of arbitrary, like this one. Who decided 1.5 right there? Why not 1.4? Why not 1.6? There's no real good answer to that. So we just have to go for it. That's how we define what an outlier is, and we go for it. We'll do some outliers on the next page. This is called a modified box plot. If you have outliers, you have to do a modified box plot. You do not include the outliers as your whiskers. So I'll explain that on the next page here. Okay, next page. Example 4. We're gonna make a box and whisker plot. We're gonna make a modified box and whisker plot. So example 4, we've got Big Mac prices for 44 different countries, so there's 44 pieces of data here. Okay. And it is already in order from least to greatest. And it's real nice because there's 4 rows, which means this is the bottom 25%, this is the lower middle 25%, upper middle 25%, and the highest 25% here. So it's nice that everything's already kind of quartered out. That's real nice. So we can do the 5-number summary pretty straightforward here. So what is the minimum? 5-number summary, 1.84. What is Q1? It's going to be the middle of these two. It's the middle of here's the lower half right here. And so we have to average these out. So what's the average of this number and this number? That will be the Q1. 2.455 would be the average of those two. The median. What is your middle number? In this scenario, we have to take this and average with this. So what's the average of 3.08 and 3.33? So add them up and divide by 2. you're going to get 3.205. Okay, so just averaging these out. What's the upper quartile? Upper quartile. You are taking the middle of the upper half, so you're going to average these two out. What's in the middle of 3.83 and 3.84? 3.835. And then the max, oops, I ran out of room. The max is 7.20. So there's your 5-number summary. 5-number summary. The interquartile range, if they asked you, would then be 3.835 minus 2.455, which is 1.38. That would be your interquartile range, which we'll need that to find the outliers. The outliers are based off of the interquartile range. It's part of how we define that. Okay. So the lower boundary for the outliers is Q1 minus 1.5 times the interquartile range, which is 2.455 minus 1.5 times 1.38, which is what we just found right there. It's the interquartile range, Q1, interquartile range. And for that value, we get 0.385. So that's the lower boundary. Are there any numbers in my data set that are less than 0.385? No, there are not. So there are not any low outliers. Let's check for upper outliers. The upper boundary is Q3 plus 1.5 times the interquartile range. So that would be 3.835 plus. So we're looking on the other side, which ends up being 5.905. And it looks like we have ourselves some outliers. Are there any values that are larger than 5.905? That one, and that one. Those are larger. So these are outliers on the high end. So yes, we do have some outliers there. That's how you define it. Simple little process there. Draw a modified box plot for the data. Okay, so what you do is you go and you plot your outliers. So we got 720. Let's run it. You put like a line like this, which includes the lowest and the highest values. So 720 is about right there. 656 is about right there. And 619 is about right there. So that takes care of my my outliers, and you might even see them as X's as well instead of dots. It just depends on who wrote the book. All right, now you go in and you put in now your maximum value, 4.91, and this is right here. And then you can put in your minimum value, 1.84, which is right about there. And then you put in your quartiles, 2.45, about there. Your median, 3.2, and your upper quartile, 3.8. I got that point wrong. I'm sorry. 4.9 is right there. Silly me. 3.8. Okay. So this looks a little complicated. These are your outliers. This is called your whisker on your high end, not including your outliers. This is your box. There it is. This is called a box skin whisker plot. You got your max, not including your outliers. This is called a modified box and whisker plot. You do not include the outliers. This is Q3. That's your median. That's Q1. And that's the min. This is called a box and whisker plot. Because it looks like a cat, I guess. I don't know. Describe the distribution. These points here are pulling the typical value to the positive direction. This is positively skewed. Alright, the mean will be more than the median. So here's the middle, and the mean is going to be pulled this way. So the mean is going to be more than the median. Mean is more than the median due to the outliers. And you'd also want to hit things like spread. If you have outliers, should we use standard deviation or should we use interquartile range for spread? We want to use interquartile range, so we'd want to state that the interquartile range is 1.38. The shape, it's skewed positive. Outliers, we want to mention the outliers. Center, we can say the median is here, but the mean is more than the median due to the outliers. And then spread, interquartile range. We hit socks, remember socks? That's what you want to hit when you describe a distribution. Next, how does the mean price of Big Macs compare to the median price? Alright, so to calculate the mean price, we can use that notation right there. We found that the median, which doesn't have a symbol, is 3.205. And the average, I already talked about this, the mean is more than the median due to the outliers. To find the average, you're going to have to add all these up and divide by 40. I didn't do that. I should have done that beforehand. There's actually going to be another video on here that's going to show you how to do all of this in your calculator. This beautiful calculator you have here. That's going to be on a video. I'm just going to post that. You're going to have to watch that on your own. And that's going to save you so much time on your homework. Alright, put it all together. Here we go. We want to select appropriate measures of center and spread. So you need to look at the shape of the distribution. If the distribution is symmetric, then you use standard deviation for the spread. If the distribution is skewed, you use interquartile range for the spread. Let's remember back to the first page. If the distribution is approximate, symmetric, you also use the mean for the typical value. If it's skewed or has outliers, you use the median for the typical value. Okay. Compute the values of selected measures. Interpret the values in context. This is going to be a big deal on getting points on the free response. Interpret in context. So we'll do some examples of free response. And I'm just about out of time, but here's some stuff. There's your homework. It's due Thursday, beginning of class.